Hi students, we completed activity 7 from lesson 2, that is friction. Now let's move on to the activity 8. Activity 8, effect of rollers on friction. Effect of rollers on friction. So this is activity 8. We already completed activities till 7. So this is the 8th activity, effect of rollers on friction. Okay, effect of rollers on friction. So this is the concept. So what do you mean by this effect of rollers on friction? What do you mean by rollers here? Which rolls? Okay, example, a marble. When you push this marble, so what happens? How it moves from place to place? Okay, it moves or it covers distance by rolling. Okay, are these rollers show any effect on friction? Are these rollers show any effect on friction? Yes, it shows effect on friction. Which shows effect on friction? Rollers show effect on friction. Which are said to be rollers? Objects which rolls, we call them as rollers. Objects which rolls, okay, which rolls, we call them as rollers. Example like wheels, marbles, ball bearings, all this comes under rollers only. Let's see. So there is a bag. Okay, we will be having a trolley bag. Okay, we will be having a trolley bag. So it is attached with wheels. These are wheels. Attached with wheels or fixed with wheels. Okay, fixed with wheels. And I'm having another bag. This is the other bag which I had. So I don't have the wheels. Okay, wheels are not fixed to this one. Okay, I had only the handle for this. I had only the handle. Okay, no wheels for this. Okay, no wheels are attached to this one. Remember, try to understand. Two bags are there. One is with wheels and other is without wheels. So to carry this from place to place, I want to carry nearly about 50 meter distance or 100 meter distance. Nearly about 50 meter distance or 100 meter distance, I want to carry this both the bags. On which object or on which bag I can exert less force? On which bag I can exert less force? So obviously upon this, okay, I exert less force. With a single hand, or with two fingers or with one finger, I can drag this whole load or this bag easily, whatever the distance it may be. Maybe it is about 50 meter distance or 100 meter distance or 200 meter distance. Whatever the distance it may be, if the surface is plain, it can be carried, okay, or it can be dragged easily. And applying the same force or applying the same effort on this bag, can we carry or can we drag this bag easily? Okay, how we drag the first bag? No. Okay, we need to apply excess of effort. We need to apply more energy. We need to apply more force to drag this object. Why? Because its contact area is high. Its contact area will be high. Whereas for this, contact area is less. Wheels, contact area is less. Okay, wheel, okay, it touches the ground in a very small, okay, region, okay, small area, it touches a small area. It's the wheel area, okay, a small area of wheel, it is in contact with the ground. Area is small. Okay, if area is small, the friction is reduced. Friction reduces. Okay, friction reduces. If the friction is low, so speed is high, it moves easily. And whereas here contact area is more. Since contact area is more, friction also increases. Contact area increases, friction also increases. These are some of the factors that affects the friction. So contact area is more, friction also increases, friction increases. So we need to apply more effort, we need to apply more energy. Okay, this is one example for the effect of rollers on a friction. And let me go for the other example. This is a toy trolley. Okay, so I'm trying to pull this. And I'm having other object. This is also a toy trolley with the same size, same measure. So, but this is having wheels. This is having wheels. These both are dragged in this direction, which can be dragged easily. Okay, obviously this can be carried easily. This can be dragged, or this can be pulled easily, because okay, contact area. Okay, here wheels are present. Here there is no wheels. There are no wheels. Contact area is more, whereas contact area is less. So contact area is less, so friction reduces. Friction reduces, can be dragged, can be carried easily. Okay, so by this example we can say rollers, they show effect on friction. If rollers are there, friction decreases. If rollers are there, what happens? Friction decreases. If friction decreases, what's going to happen? Can be moved easily. Its speed increases. It can be carried easily. That's what. And now let's move on to this other. And the friction which is produced here, the friction which is present here, what do we call this as? We call it as rolling friction. We discussed already. Types of frictions are there. One is rolling friction. Next one is static friction. Another one is sliding friction. This here rolling friction. Here the rolling friction takes place. Which friction takes place here? Okay, here we observe sliding friction. Next, coming to the other activity. Activity 9, understanding the principle of ball bearings. Principle of ball bearings. In fan, ball bearings are present, and also in a cycle wheel, especially the back wheel, if you observe or if you note at the center, okay, where the axle is there, so between the axle and the wheel, okay, this is the wheel, and this is the axle, okay, AXLE. And around this, okay, what this mechanic will do means he will apply some grease. And he will place, okay, around this one. So he apply the grease. This is the grease, and he applies, or he inserts ball bearings, metal balls are placed. If you have a chance, visit the bicycle mechanic who repairs the bicycles. Ask him once, what is the reason behind this? Why he should apply the grease and also insert ball bearings, metal balls around this? What's the reason? What's the importance? Ask him once if you get a chance. What happens here is, this grease, it acts as a lubricant. What do we call it as? It acts as a lubricant. LUBRICANT. It acts as a lubricant. And even this ball bearings also behaves as a lubricant. What is a lubricant? A substance which decreases the friction and increases the speed. We call it as a lubricant. Oil, it is a lubricant. Graphite, GRAPHITE, graphite is also a lubricant. Grease, it also behaves as a lubricant, which reduces the friction and increases the speed. That material, that substance, we call it as a lubricant. So now here this both, it behaves as a lubricant and makes the vehicle, makes the cycle to move faster. Did you understand? So in the same manner, okay, what's the importance of this lubricant? Okay, what's the importance of this? Okay, understanding the principle of ball bearings. So this ball bearings, they are important. Okay, they are helpful for us in movement. They are helpful for us in reducing the friction. They are helpful for us in increasing the speed. They are helpful for us. Which are helpful for us? Ball bearings are helpful for us. They helps us in applying less effort and carrying a huge load. Applying less effort and carrying a huge, more load. That's what about this ball bearings. And next come into this other one, that is activity 10, fluid friction. Fluid friction. Here, which are said to be fluids? Okay, this is activity 10. Observing fluid friction. Observing fluid friction. Observing fluid friction. First, what are said to be fluids? Any substance which can flow easily. Any substance which can flow easily, we call them as fluids. We call them as fluids. Substance which flows easily, free flow. Example, all the liquids comes under fluids. All the liquids comes under fluids. They can be flowed easily. They can be flowed easily. And all the gases also comes under fluids only. Gases and liquids comes under fluids. Here, observing fluid friction means friction in fluids. Friction in fluids. Will be observing friction in fluids. Do you think the friction acts or the friction is present in liquids also? Do you think this friction is present in fluids, that's in gas, and also in liquids? Yes, it is sure, the friction is present, in liquids and also in gases. Let's see, there is an activity for you. This is the glass I have taken. So in this glass, I took some water up till here. This is the water quantity which is present. What is this? This is water which is present, H2O, molecular formula for water. Now taking a spoon or a stirrer, taking a spoon or a stirrer, I swirl this water. I rotated this inside. I made this to rotate. Now this water, it is turning around. It is turning around like this. Water, it is turning around. Water, it is turning around inside the glass. Make sure this is a transparent glass. What is this? It is a transparent glass. Transparent glass. And this is the stirrer. 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 So this may be a spoon or glass rod. Spoon or glass rod. Glass rod. So it is stirred thoroughly. Now the water is swirling. It is turning around like this. So leave that like that without any disturbance. What do you observe? After some time, we know that this water, it comes to rest. This water, slowly it reduces its speed. Slowly it reduces its speed and finally comes to rest position. Comes to rest position. What might be the force which is making that to come to rest? What might be the force? Can you guess once? So there is a friction. Frictional force makes that to comes to rest. The molecules which are present. The molecules which are present inside. I told you, this water, it consists of water, H2O, water molecule, H2O. So many water molecules, H2O molecules are present. In this one, numerous water molecules are present. Numerous water molecules are present. Inside this water, numerous water molecules are present. We know liquid molecules, they are far to each other like this. Molecules, they are far to each other like this. All these are molecules. Each one is said to be a water molecule. This is said to be a water molecule. Each one is said to be a water molecule. there will be a friction between all these molecules. There will be a friction between all these molecules. Okay, they rub with each other, they collide with each other, they hit with each other, and finally, because of this friction, because of the frictional force between which is present between these two molecules, so makes that whole liquid to come to rest in position. It comes to rest in position. Okay, this is one of the activity to show, okay, to observe the friction in a fluid, and other one, not only that, okay, you can take a tub, take a bucket, if not a tub. This is the bucket I have taken. This is the bucket. This is the bucket. Okay, inside this also it is filled with water. It is filled with water. Keep your hand in. Insert or allow your hand inside. Allow your hand inside. Okay, try to rotate. Try to rotate whole water. What do you observe? We see all this water, it swirls around, it turns around like this. Okay, remove your hand and try to insert any object inside. Try to insert object inside. Try to insert any object. Okay, try to insert one of the object inside. Do you think it remains like that only without any disturbance? No, this will be, okay, that object will be moving like this. It starts to move. So what makes this object to move around? When you add some other pieces, okay, pieces of paper or any other, okay, which are light in weight, when you drop some objects inside, so what's going to happen? We observe these objects, they also rotates along with the water. What makes that to rotate? Yes, okay, that's correct. Okay, here what the friction which is present are the fluid friction. Fluid friction makes that to rotate. The same time, after some time, we see all these molecules, they comes to rest in position, or slowly it reduces the speed. Slowly it reduces the speed and comes to rest in position due to friction. What friction is present? So friction between what? Friction between the this tumbler or this bucket, okay, tumbler or this bucket wall, and also between the molecules of the water, so there is a friction acting upon this, finally makes this liquid to come to rest in position. Okay, that is the other activity. Okay, next, frictional force exerted by fluids is also called drag. One more point, that is here drag. What is drag? The frictional force exerted by fluids. The Frictional force exerted by fluids. Frictional force exerted by fluids is called drag. Here, what is drag? Okay, what is drag here? Drag is nothing but the frictional force which is exerted by fluids. Frictional force which is exerted by fluids is known as drag. So means here drag is applied, drag is present. What is drag here? Drag is nothing but the frictional force exerted by fluids. Which are said to be fluids? Which are said to be fluids here? Which flows easily? We call them as fluids. Example like all the liquids and also gases comes under fluids because they can flow easily. Okay, so what is drag here? Drag is nothing but frictional force exerted by fluids is called drag. And now let's move on to the other activity, that is 11th activity, and this identifying factors influencing the fluid friction. Identifying the factors Did you understand, everybody? Is it clear for you about this? Frictional force exerted by fluids is called drag. That's the one of the important point that you should understand in this one. Okay. Now let's move on to the other activity, that is 11. Be alert, everybody. Activity 11, this is identifying factors influencing the fluid friction. Identifying factors influencing fluid friction. What's the topic? Identifying factors influencing the fluid friction. Did you understand? Okay, identifying, we should know, we should find out. Okay, so we should observe. Identifying are to know factors. What are the factors that influences, that change, that affects? Okay, what are the factors that affects the fluid friction? Okay, so this is the topic for this. Okay, shape, mainly shape is one of the factor. Okay, so first one we'll go for shape. This is very important. Second one is its mass. So these are some of the factors that affects influence the fluid friction. So we see many objects, they'll be moving in water bodies, and many objects they'll be moving in air. Like birds, they move in air, they fly in the air. And what about this aeroplane? Even it flies in the atmosphere, it flies in the air. And why those organisms can fly, and why can't we people fly in the air? Birds, they can fly, but all birds cannot fly. Duck, does it flies? No, duck cannot fly. Why it cannot fly? It cannot fly because of its mass. It is having higher mass, more mass. So what's there? Okay, even many other birds are there which are very heavy compared to this duck, but still those can able to fly. But this duck being smaller in size compared to the other vultures, eagles, compared to those, this duck is smaller, but still this cannot able to fly. What's the reason? Yes, this cannot fly to long distance because those birds, they contains pneumatic bones. Those birds which can fly, they contains pneumatic bones. Okay, inside the bones we observe air is filled, air is present, which makes the whole body to be light in weight. Which makes the whole body to be light in weight. And also their structure, their body structure, it's very important. Okay, as we'll have a streamlined shape for those. We observe a streamlined shape, stream, S-T-R-E-A-M, streamlined shape. Streamlined shape is present. Okay, what is present? Streamlined shape is present. So because of this particular shape, they can fly easily, and also because of presence of a lightweight bones, and their wings, the feathers also little different compared the pattern of the feathers. It is also little different compared to this duck, hen. So only those birds, they can able to fly to a long distance easily. They can take off easily. Okay, and next, so if you observe this other fishes, sharks, dolphins, whales, other fishes, they move easily and very fast in water bodies because of their specialized structure. A streamlined shape makes those organisms to move faster and in water. Do you think there is no friction? Even there also friction is present. Even in water bodies, friction is present. When this fish is moving in water, it should make all that water to be, it spits all that water molecules, it makes away and moves further. Even this water exerts force or friction upon this one. There is a friction between this body of fish and also the water body, water molecules. There's a friction between this both, but still it moves further. But it exerts more force. It overcomes that friction which is exerted by the fluids. By exerting more force, it can move further. What I mean to say here is, even one more point here, that is boats, ships, those can move further in water bodies by splitting all water molecules aside. It moves further. So because even there also there is friction. So there also it is friction. Here think there is a ship, it is moving further with the help of engine. Once if the engine is stopped, does this ship move further or it stops? After some time we observe this ship, it stops, it comes to rest position. What makes that to come to rest position? The frictional fluid friction makes that ship to come to rest position. Even fish which is not swimming, which can after for some time it swim in the water, later it stopped its swimming. What happens? It lowers its speed, it drowns down. Why? Because of friction exerted by the fluids. So here, fluid friction acts upon different objects which are in fluids, which moves in fluids. So identifying factors influence in the fluid friction. So mainly shape is there. Shape is affected by fluid friction. Okay, and also its mass. If mass increases, friction also will be high. If the shape is not streamlined, if the shape is rectangular or square in shape, the friction will be high. If it is having a streamlined shape, so that object or that animal can move easily further. Okay, so these are some of the factors that affects the identifying the that affects the fluid friction. So with this, we completed lesson 2, friction.